Hi, in this lecture, we'll focus on finding one-sided limit from the left and from the right. Let's take a look at this example. One-sided limits is whenever we see the superscript of plus or minus right on top of that x value that we are looking at. So, since there is a plus here, this means we are looking at 2 from the right side, and the value of the limit, which is the value of y for this graph, is equal to 3. And then when we try to look at the value of x from the left side, where it has a superscript of negative, the value of the limit is 3 because the y is approaching to 3. This is what we call as the limit in the graph is two-sided because we can find the value of the limit from the left and also from the right side of function f. But what about this graph? Is it a one-sided limit or two-sided? Well, from the right side of 0, we can see that the value of the limit is approaching to 2.718. But the value of the limit as x approaches to the left side does not exist. Why doesn't it exist? That's because there's no graph on the left of 0. This is where we say that the limit in the graph is one-sided because the value of the limit only exists on one side. Note that a one-sided limit can either be a right-hand limit or a left-hand limit. And for this case, this is a right-hand limit because the value of the limit only exists on the right side. As a conclusion, the right-hand limit is whenever as x approaches to a from the right side. And left-hand limit is whenever the x approaches to a from the left. Let's look at this example. In A, we want to look at what is the value of the limit. Remember, the value of limit is the value of y on our graph. As x approaches to negative 2, and this is our x, negative 2 is here. Negative sign on top here means it's from the left of negative 2. So, is there any graph on the left of negative 2? Since there's no graph on the left of negative 2, so the limit does not exist. Now, question B, still at the same value x equal to negative 2, but from the right side of negative 2. Does the limit exist? Do we have a graph approaching to negative 2 from the right side? Remember, limit is finding what is the value as it approaches to that x, not right at x. So, do we have a graph approaching to negative 2 from the right side of negative 2? So, from the right side of negative 2, can you see that there's this graph which approaches to negative 2, but it never reaches that because it's an asymptote. So, as you can see, the graph approaching to negative 2 from the left side, the value of y of the limit is approaching to negative infinity because as we go down, the graph is approaching nearer and nearer to negative 2. And the value of the y there is just negative infinity. What about 0 from the left side? So we look at the value of 0 on our x-axis, and then we look at the y value as it approaches to 0 from the left side. So from the left side of 0, where is it approaching to? It's approaching to the value of y equal to 1. Next, what is the value of the limit as x approaches to 0 from the right side? So on our x-axis, look at 0 and then look at what is the graph approaching to from the right side of 0. As you can see, the graph is approaching to the value of y equal to 1. So the value of limit is 1. Example 2. Find the limit of fx as x approaches to a from the right side and the limit of fx as x approaches to a from the left side for any given a. And in a, our a is 1. So this means we want to find the limit as x approaches to 1 from the right and also from the left of function f. Remember, start by drawing your number line because this helps you to determine the function that we will choose for the left side and also for the right side of the limit. Let's take a look at our piecewise function. We have two functions. One is 0, another one is 2x minus 1. 0 is exactly at x equal to 1. So if this is our number line, this is 1. So fx equal to 0 is just a dense circle here, and it's a point 0. What about 2x minus 1? The domain given is x not equal to 1. So what does that mean? That just simply means it's everywhere else besides x equal to 1. So at x equal to 1, we have an empty circle. And then everywhere else is just a function 2x minus 1. Now let's take a look at the function for x approaching to 1 from the right side of 1. So on our number line here, from the right side of 1, the function is 2x minus 1. So replace fx with 2x minus 1. After that, substitute your value of x into the x of the function f. 2 times 1, solve it, you get 1. Next, from the left side of 1, replace your function. The function is 2x minus 1, and then substitute your value 1 into the x. What you get is 1. Look at the question again. The question wants you to find the limit from the right side and also from the left side of function f. But the question doesn't even want you to find what is the value of the limit as x approaches to 1. So for this question, we do not have to conclude that the limit of x approaches to 1 exists and the value is 1. Next example. Fx is this piecewise function, and we want to find what is the value of the limit as x approaches to 2 from the left and also 2 from the right side. So 2 from the left, plot it on your number line, is the function 3x squared minus 6. Why is it empty circle here? Because there's no equal sign. And then why is it dense here? Because that's equal sign. On the right side, the function is 8 minus x. On the left side, the function is 3x squared minus 6. Write it down. Next, determine what is the correct function from the right side of 2. So from the right side of 2, look up, you will see the function is 8 minus x. Replace it there. And then substitute your value of 2 into the x. Your value of limit is 6. Look from your left hand side. Your function from the left hand side is 3x squared minus 6. Replace it. And then substitute your value of 2 inside. Next, simplify and you get your value of 6. Just stop until there. You do not have to write your conclusion. Because remember, the question just wants you to find what is the limit from the left and also from the right side. For example 3, we need to find the limit as x approaches to negative 2 from the right side and also x approaching to negative 2 from the left side of the function fx. But this is not a piecewise function. It's not the same as in example 2. So since it is not a piecewise function, this means that we only have the same function for both from the left and also from the right side. But when you try to substitute your value of negative 2 into the x, what you get is 0 over 0. Remember, in the previous lectures, we have learned that whenever we get 0 over 0 for the value of the limit, this is not the answer. It's just an indicator that tells you that you have to use the method of factorization or the method of multiplying conjugate. So which one is it for this case? Remember, to multiply conjugate, you can only use that method whenever there is surd or square root. But there's no surd for this question. It's just an absolute function. So we have to use the method of factorization. And to factorize, we have to first split your absolute function to a piecewise function. To split absolute of x plus 2, first start by writing x plus 2 positive and then write negative outside with the bracket of x plus 2. Next, just equate x plus 2 and write it greater and equal to 0 to find your first domain. When you bring positive 2 to the right side, you get negative 2. So the other piecewise function would be the opposite. If this is greater than and equal, so the opposite is just less than, negative 2. After that, since our function fx is not just absolute of x plus 2, it is absolute x plus 2 over x plus 2, then we have to divide each of this with x plus 2. Copy the same functions and then just divide it with x plus 2. The domain will stay the same. And up to this part, this is what we want. Remember, in the previous lectures, whenever you use the method of factorization, because the limit is 0 over 0, what you want to achieve is you want to cancel off a linear factor, at least one linear factor. So is there anything that you can cancel off? Well, here, yes, you still can simplify. X plus 2 divided with x plus 2 is 1. And then you can also simplify the other, but there's a negative sign in front. The domain still stays the same. After that, you can draw a number line. The value of x is negative 2. And then to the right side, and thence is the function positive 1. And then from the left side of negative 2, it's empty circle. And the function is negative 1. Now, what is the value of the limit as x approaches to negative 2 from the right side? So from the right side of negative 2, you will see that the function is positive 1. So replace the function with positive 1. Since positive 1 is just a constant, so the answer is just 1. Next, what is the value of the limit as x approaches to negative 2 from the left side? So from the left side of negative 2, the function is negative 1. So the final answer is just negative 1. So just leave your answer like this. In this example, we have quite a few domains given. So it's helpful if you can draw the number line. To draw a number line, first look at the value of x. The smallest value of x is 3, so write 3 on your number line. And then the next value that we have is 5. Right, and then the first function is an empty circle because it's x less than 3, no equal sign. And to the left is this function. Okay, the next function we see is 2, but it's at exactly at 3. So thence at 3, the function is value 2. Next, at 3, empty circle, until 5, then circle, the function is x plus 5. After that, empty circle at 5 and greater than 5 because the arrow is going to the right, the function is 10. Now, let's answer the first question. Limit of fx as x approaches to 3 from the left side of 3. So from the left side of 3, what is the function? The function is this quadratic divided with the absolute function. First, write down the function. And then, remember your first step of finding limits, try to substitute the value of 3 into the x. After you substitute your value, you get a 0 over 0. So this means that you have to factorize or multiply with conjugate. But for this question, there's no surd, so you have to factorize. And to factorize, you have to look at your absolute function. Start with that. Remember, you have to split this into a piecewise function. The first one is just copy down exactly the same. The next one is writing a negative sign outside and put a big bracket. And after that, write down your domain. Domain is just looking at the function inside and just write your inequality sign greater than or equal to 0. And then after that, just bring 3 to the right side and leave x on the left side. So that's your domain. The other domain will be just the opposite. So it's just less than. After you have separated your absolute function, x minus 3, to a piecewise function, take a look at your domain for the first function. The domain is x less than 3. So this means that this whole function only exists from the left of 3. This means we only take the negative part of the piecewise function, not the positive side, because we only look at x less than 3. But fx is not just absolute of x minus 3. Fx is x squared plus x minus 12 over absolute of x minus 3. So since absolute of x minus 3 from the left side of 3, or as x is less than 0, we know that the function is negative. So we can replace that with the negative function. So it's just negative x minus 3. But remember, after we have separated this absolute to a piecewise function, the next thing that we have to do whenever we get limit as 0 over 0 is we have to cancel off at least one linear factor. But we have not cancelled it off for now. So when you try to substitute your value of 3 into the function f right now, you will still get 0 over 0 because you still have not cancelled off the linear factor. So this means we have to also factorize the numerator. So how to factorize the numerator? It's just x minus 3 times x plus 4. And then you cancel off that linear factor. What's left is just substitute 3 into the x and you get negative 7. Now, the next question is finding the limit as x approaches to 3 from the right side of 3. From the right side of 3, the function is just x plus 5. Remember, it's not exactly at 3. So we are not going to take the function 2. Replace your function f with x plus 5. Next, substitute 3 into that x. Your final answer is 8. Next question wants you to find what is the value of the limit as x approaches to 5 from the left side of 5. So from the left side of 5, the function is x plus 5. Replace that with your f. After that, substitute your value of 5 inside. 5 plus 5 is 10. Next, from the right side of 5, what is the function? So from the right side of 5, the function is 10. Replace fx with 10. Since 10 is just a constant, the final answer is constant 10. Thank you for watching.